Today, we're going on a trip deep into space. We're headed for a place that's both stunningly beautiful and, believe it or not, pretty chaotic. It's a stellar nursery called Caldwell 9, but you probably know it by its much cooler name, the Cave Nebula. All right, take a look at this. At first glance, the Cave Nebula just looks like this peaceful, cavernous cloud kind of floating through the cosmos. But you can't let that calm look fool you. Because inside this massive structure of gas and dust, something really powerful is going on. Brand new stars are being born. So, to really get a handle on this cosmic birthplace, we first need to zoom out a bit and figure out where exactly it is on the grand map of our galaxy. And first, let's just talk about scale, because it's mind-boggling. The Cave Nebula is about 2,400 light-years away from us. To put that in perspective, the light that's hitting our telescopes tonight from this nebula actually started its journey toward Earth right around the time the Iron Age was getting started. Yeah, a long, long time ago. Okay, so you can find it up in the northern sky in the constellation Cepheus. But here's the really cool part. This glowing cave-like thing that we see, it's actually just the brightly lit up edge of a much, much larger, colder, and darker cloud of molecular gas called Cepheus b. So think of it like we're just seeing the illuminated entrance to this enormous, mysterious cavern. Now, you can probably see the challenge this creates for astronomers, right? How in the world do you study what's happening deep inside a dark, cold cloud that you literally can't see through? Well, let's check out the very clever tools they use to pull it off. It's a fantastic question, isn't it? If the cloud is blocking all the visible light, how do you have any idea what's going on inside? The answer is, you have to look at the universe in types of light that our own eyes just can't see. Okay, so step one is to use radio telescopes. They're not looking for light, they're mapping out the raw ingredients for stars. This image here, it's a map of carbon monoxide gas. And that's the key, because this gas clumps together in the coldest, densest parts of the cloud. So by mapping it, astronomers know exactly where all the star-making fuel is being stockpiled. So once they know where the fuel is, they switch to a totally different tool, an X-ray observatory, like the Chandra X-ray Observatory. See, newborn stars burn incredibly hot, and they give off these powerful X-rays that can just slice right through all that dust that's in the way. This lets astronomers basically take a head count, a census, of all the little baby stars hiding inside. And of course, there's a scientific name for these baby stars. They're called young stellar objects, or YSOs for short. These are basically stars in their infancy, still wrapped up in their dusty cocoons, and actively pulling in more and more material from the cloud around them to grow bigger. Okay, so we've got the ingredients mapped out and we can see the newborn stars. But what kicked this whole process off in the first place? What's the engine that's actually driving this whole star factory? Well, it turns out the culprit is just one single gigantic star. Meet HD 217086. It's a ferociously hot and brilliant O-type star, which is one of the most massive and luminous kinds of stars there is, and it's sitting just outside the cloud. And its immense energy is what's reshaping this entire region. This whole thing is a process called triggered star formation. Let's break down how it works. First, this massive star, HD 217086, is just shining with incredible intensity. Its radiation and its stellar winds act almost like a cosmic snowplow, just carving out this huge cavity in the gas around it. This creates a shockwave, a powerful front that slams into the cold gas of the Cepheus b cloud, compressing it. And that compression, that squeeze, is the crucial trigger. It squishes the gas until it gets so dense that it collapses under its own gravity and poof, a whole new generation of stars ignites. So by combining these completely different views, the radio map showing the fuel and the X-ray view showing the fire, astronomers were able to piece together the whole story of what's really happening inside the Cave Nebula. And this is the aha moment. This is where it all clicks into place. On the left, you've got the radio map of the raw material, the gas cloud. On the right, you have the Chandra X-ray image showing the newborn stars. Now, just look at how perfectly they line up. It's incredible. The new stars are forming exactly along that compressed edge of the cloud, right where the shockwave from that massive star is doing its work. So the big takeaway here is this. All this evidence, when you put it together, confirm that Cepheus b isn't just some quiet, sleepy cloud. No way. It's one of the most active and productive star factories anywhere near us in the galaxy, just absolutely bustling with these young stellar objects. But wait, the story actually gets even cooler. It turns out Cepheus b has a sibling cloud right next door, called Cepheus c, and this provides a perfect natural experiment for scientists to help us understand even more. And this slide just lays out that contrast perfectly. Cepheus b, the one we've been looking at, is this hotbed of activity, clearly being triggered by that big star nearby. But its neighbor, Cepheus c, is really quiet, almost dormant. It hasn't gotten that powerful external push yet, so it's forming way fewer stars. And this is why this all matters so much. By comparing these two clouds right next to each other, scientists can start to isolate the exact conditions you need to kick off a massive burst of star formation. It's almost like having a control group for your galaxy-sized experiment. In fact, as the researchers who studied these clouds put it, this contrast is what makes them so incredibly valuable for figuring out how star formation really gets going across our entire galaxy. So we have the trigger, we have the starburst in one cloud, and we have the quiet neighbor next door. What does this all mean when you put it all together? I think the most important thing to take away from this is that the universe is not just a static collection of pretty pictures. It's a dynamic, interconnected ecosystem. Places like the Cave Nebula show us that stars don't just pop into existence in isolation. The life and death of one generation can directly kick off the birth of the next in this amazing, cascading cycle of cosmic creation. And that kind of leaves us with one last really fascinating question to think about. The story of the Cave Nebula was only uncovered because we learned how to look at the universe in different ways. So it makes you wonder, what other incredible cosmic engines are out there right now, carving new worlds from clouds of dust and gas, just waiting for us to find the right way to see them?